How do transverse and longitudinal waves differ in GED physical science? Imagine you're at a pond watching ripples on the water. Some waves move differently than others, and understanding these differences helps explain how waves work in our world. Today, we're exploring how two main types of waves, transverse and longitudinal, move and transfer energy. This is a key part of GED physical science, especially in the section about waves and sound. First, think about how particles in the medium move when a wave passes through. In transverse waves, particles move up and down or side to side, at right angles to the direction the wave is traveling. So, if the wave moves forward, the particles are moving perpendicular to that movement. Picture a wave on a string or water ripples. The peaks and valleys, called crests and troughs, are features of transverse waves. The distance between two crests or two troughs is called the wavelength. Now, for longitudinal waves, particles move back and forth along the same line as the wave travels. Imagine pushing and pulling a slinky. The coils move forward and backward, creating areas where particles are close together called compressions, and areas where they are spread apart called rarefactions. The wavelength here is the distance between two compressions or two rarefactions. Another difference is where these waves can travel. Transverse waves usually move through solids because particles need to be tightly packed to move perpendicular to the wave. Water waves and seismic secondary waves are good examples. Longitudinal waves can travel through solids, liquids, and gases. Sound waves are a perfect example because they can move through air, water, and even steel. Both wave types transfer energy, but their particle movements are different. Transverse waves transfer energy as particles move perpendicular to the wave's direction, while longitudinal waves transfer energy with particles moving parallel to the wave's movement. In terms of sound, the loudness depends on how big the compressions and rarefactions are, which is called amplitude. Larger amplitudes mean louder sounds because the particles vibrate more intensely. Knowing these differences helps us understand many everyday phenomena. When you hear sound, you're experiencing a longitudinal wave. When you see light or water ripples, you're observing a transverse wave. Recognizing how particles move in each wave type makes it easier to grasp how energy travels through different media in our world.